Okay, so on the second conservation of momentum assignment. So it's like all the great conservation laws, whether it's charge, mass, energy, doesn't make any difference. They all follow the same format. The sum of the momentums before has to equal the sum of the momentums afterwards. Now, the unique thing about momentum is that you can start with the sum of the momentums equal to 0. Okay, so like you have two people facing each other, the carts that are going to go bouncing off like we're going to do in the lab today. So you can have the sum of the momentums equal 0 Newton seconds. Now, and you can still then have something happen. Obviously, that doesn't work with mass. You can't say, oh, I have no mass at the beginning of the reaction, and then afterwards I'm going to have a positive and negative mass, which are going to add up to equal to 0. Okay, because mass is a scalar quantity. Momentum is a vector quantity. Same thing is true of energy. Energy has to be conserved. Energy is a scalar quantity. We're going to get that into next. So the unique thing about momentum is that you can have no momentum to start with, but then afterwards, the momentum still has to add up to equal to 0. They just have to, the magnitudes have to be equal and opposite. Okay, so let me give you some hints. On the problems that I gave you, both of your answers on 7 and 8 should start with a 2.
Theoretically, for 7, I got a -2.
No, you didn't.
Okay.
Easy fix.
Oh yeah, just erase the negative sign.
Yeah,
That'll
I'm sure.
fix it.
I'm sure.
Fix your clock.
Huh?
Oh yeah, it's not 9:45 or 8:45.
You
We
have to
just
hold them.
like-
You have to take them outside and hold them and all kinds of fun stuff. Blow your nose 3 times.
Most random thing I've ever had happen in this room. Okay, anyway, back to our story. Let's talk about number 7, for example. So if you look on number 7, what color is that on?
Oh yeah, I'm just being really stupid.
Purple. Oh, this is-
With the yellow.
So here's the story on number 7.
Wait, what was
You got a
that?
bullet in a block. So start off with this. You go the momentum of the bullet plus the momentum of the block equals the new momentum of the bullet plus the new momentum
Yeah.
of the bullet. Okay? That's it. They all start the same way. So what happens on number 7, bullets moving 475, bullet passes through the block leaving at 275, the block is at rest. How fast is the block moving when the bullet leaves? So if you let's say, hypothetically, you end up with a negative velocity. So here's what you're telling me. Is that a bullet comes in, hits this block, the bullet exits the block,
Yeah, no.
and then the block ends up going in the opposite direction.
No.
Yes,
Yeah, yes, but no.
that's what you had. Was it
So,
not?
Does it go through the block and then just like go back to the hole, or?
Huh?
Yeah,
Do
just changing
475
velocity.
minus 275? That's the only way you can get a
Yeah.
negative.
No,
No, that'd be positive. Yeah,
Yeah, that's what you're supposed to do.
because that's initial minus
Yeah.
final.
But here's the point.
So the
Block
delta.
is initially at rest, right?
Yeah.
So you have the mass of the bullet times the velocity of the bullet initially
0.035. Yeah.
is going to equal the mass of the bullet times the new velocity of the bullet plus the mass of the block times the new velocity of the block.
Oh, that is not how I set that up.
That's the only way you can set it up.
Well, that's not how I set it up either.
So
This is the law of conservation of momentum. This is how all these problems work.
I had like the change of momentums would be the same.
Hey, I did it right.
I think I did it right too.
What do you guys get?
For 7?
Yeah.
2.8.
Positive
Yeah, that's 2.8 as well.
Okay.
yeah, I got 2.8. Well, I got -2.8, but
It's
That's just Cohen being Cohen.
No, that's just.
So erasing the negative did work.
Anyway, this is the law of conservation of momentum. This is how you want to do these problems.
Oh,
Just get rid of that.
because what
Okay.
this
Get rid of
is,
that
because this
negative.
ends up representing that
All
which
right,
can't.
so
Okay.
let's talk about number
I
10.
can
Because if
do it
your
like
answer
this.
to 10A is wrong, everything is going to be
What do you get for
wrong.
8?
So here is this inclined plane.
Okay.
Here's your block sliding down. What's the only force acting on the block?
Force parallel.
Force parallel. You do have gravity, you do have your normal, but the only thing that's going to impact that is your force parallel. Is your force parallel also your net force? Yes, because there's nothing else, right?
Yeah.
So if you can find your force parallel, which is the same as your net force, which is going to equal mass times acceleration, then you have to find the mass of the block, because I gave you the weight of the block. Then once you get your acceleration, then you need that equation,
Oh, I did exactly that.
okay? So you're gonna find your acceleration, put that in there. So your velocity on 10A should be a little bit above 3 meters per second.
Oh, we should get D, but we have different.
I have no clue what I'm doing.
There's
I'm getting the
or
right answer
three.
somehow, but I have no clue what I'm doing anymore.
If, would you say 3 work?
Huh?
Flat 3 meters?
No.
Would
No.
3.13 work?
That would work.
Yay!
I did not use that.
Where's my?
Is that
I-
Where's my
I
calculator?
took not 9.8 sine 30,
That works too.
which is
Okay.
4.9, and then,
That works.
Where's my calculator?
what do you for B?
Okay. All of your answers on B, C, and D, this is a huge-ish gap, Sean, but they all should be around 1.
That's
Okay.
interesting.
Did you just plug it in your calculator wrong?
I might have.
Interesting. Okay.
Oh, I think I forgot to square the number.
Colin, I
That's
think you have
probably
my
why.
calculator.
That will happen.
Oh, that's why they're so damn.
I forgot
Yeah.
to square my velocity.
I was like, I don't know where my calculator is, and I swear.
And yes, I realize I assigned number 19 twice. You guys in the first class to actually point that out, so
We get extra credit.
19 is D. Then there you go.
Oh.
Merry
Yeah.
Christmas. There's
Oh,
two
yeah, I
free
did
points.
notice that.
And now, let's talk about question 13, more of a conceptual idea.
Aha, there it is.
So if you look on question 13, you've got, well, standing center, you throw the ball in the air, why do you not move backwards? The result is the law of conservation of momentum violated. So here's the story. So if I do this and I push off on this, I go moving in this direction. So by the law of conservation of momentum, that table with much more mass should be going in the opposite direction. And in pure momentum problems, they're always set like on frictionless surfaces. It's on ice, you're in deep space, something like that.
No, I do not.
Because friction just makes it annoying. So what I just did, I didn't violate law of conservation of momentum, okay? But what I did, by virtue of the fact that that was basically tethered to the earth, by doing that, I minusculely changed the momentum of the earth, okay? So like when I jump up in the air, okay, I exert a force on the earth. The earth exerts an equal and opposite force on me. Thankfully, we don't have equal and opposite accelerations.
That
So,
would be wild.
yeah, it's valid. And so, and NASA does this, like if you're sending a space probe, like for example, here's the sun, here's the earth, and you want to get out to, say, Jupiter, okay? Well, if you time this right, it's called a gravity assist, like let's say here's Mars. So what you'll do is you'll use the gravity of Mars to slingshot itself past Mars. You don't want to go in a straight line. You basically use the gravity of Mars to gain some speed. It's called a gravity assist. And you can actually go through and calculate how much momentum Mars loses when you do that calculation. Obviously, it's not enough to really alter the path of Mars. Like, oh great, so much for that. We screwed up Mars. How do we get that back? Okay? But it's a minuscule amount, but it is something that you could actually calculate. Okay, hey, we're going to gain some momentum from that probe. That means Mars has to lose a certain amount of momentum as well. So that's how that's going to play out. On the problems 20, on problem number 20, that answer should be around 30.
Nice.
And on the multiple choice, 20 through 23, you should have no answers of C.
Uh-oh.
That's not good.
So 20 through 23, all those questions, you should have no answer of C.
Oh, bet that. What'd you get for your multiple choice?
It's like,
D A D A D
I got
A.
A. Yeah.
I like kept trying to look when you get the book, like that makes it.
So you answered 20. This shouldn't take you long. It's
I think it's around 30.
point oh. Sorry.
bro, that's like one of the easiest ones. It's
All
literally,
right, any other questions on the assignment?
12 on,
Going once?
12 on
Huh?
the back page here.
Okay.
Yeah.
So, here's how this starts, right? You have the momentum of the clay plus the momentum of the block equals the new momentum of the clay plus the new momentum of the block. They all start the same way, Gapshon. Law of conservation of momentum. So, they stick, right? They stick. It's a California problem. So what can you do over here?
Divide. No,
Runs the
Take
actor out.
take
Factor out.
And
Let's
That new
divide.
velocity, so this would be the mass of the clay plus the mass of the block
oh yeah.
times V prime. Now,
That's right.
here's the story. So, you got mass M, unknown velocity, so this is just gonna be M times V. Cool. Then, you have mass of 3M plus M times V prime. Do you know what V prime is? Yes.
Yes.
So then it just turns into an algebra problem.
It's not 13.
No, it's not 13.
M plus 1.
I really like the way 6 feels. The ink.
That's right.
6.
I'm being facetious.
Okay.
Did I do my math wrong? I thought it was 5.
Yeah.
I was being facetious. I was just. If I had to go completely blindly guess, I would have said 6.
Now, the other thing here is that they gave you information about this velocity, which isn't 0.
Mm-hmm.
So,
Yep.
because it's moving, then it's just doing the math. Does that make sense?
Kind of.
Half this unit makes sense, the other half doesn't at all.
Which half?
The half he gets wrong.
Yeah,
The half.
that one.
The half that you got wrong doesn't make sense? That would make sense. Okay. Literally, Cohen, once you get it set up, it is the easiest algebra problem in the world. You just have to watch the parameters on how it's defined. Danny?
Can you explain how you got 30 for 20? 30 kilograms for 20 on the
Bro.
textbook?
9.5 kilograms moving at 0.5 meters per second has to equal the mass of the canoe times the speed in which the canoe is moving, 0.15 meters per second.
But one of them has to be negative because they're moving in opposite directions.
Okay,
Could you
change the momentum?
I make that negative.
wait? Did I do
then
that
make
wrong? Probably because of that.
Then you go the opposite changes in momentum. So one momentum is the other.
Could you say that again?
momentum.
But I mean, like,
Cohen just said it really fast, and I can't really.
Okay, so on problem 20, here's the story to this. Dog takes a nap, wakes up, canoe's drifted out at the station yard. So here's the canoe, and here's Lassie. Okay?
What have you done to Lassie?
See, there's a zero.
Put that dog
Yeah,
out of
right.
its misery.
Okay.
Rabies?
So what's the initial momentum of the system?
Zero.
Zero. So the momentum of Lassie plus the momentum of the boat equals the new momentum of Lassie plus the new momentum of the boat. Right?
Got that.
What does this side equal?
0.
Zero. What do the other two sides have to add up to?
Zero.
Zero.
Oh. Look, you said negative 0.75 equal to. But last year,
I did not have any negative signs.
So define one of them as being, so on 20,
Wait.
then canoe sunk in the opposite direction. What was the mass of the canoe? It's just a matter of solving for that mass.
Is 31.67 kilograms, look?
I said it's around 30. Is your answer around 30?
Yeah.
Okay.
Where did you put the negative sign then?
So I put the negative sign, but since
I think
kil-
I'm doing
since mass
things
can't really
like
be negative, I
the wrong
just
way.
ignored it.
But
Okay.
I made the
Because-
right
So
answer.
just leave it at positive then.
Just focus on the
I
answer
feel like I'm
part,
doing
not the
everything the
word.
wrong way, but I'm getting the right
Oh,
answers,
that's
so I don't really
comforting.
care.
Yes.
I feel like I'm doing everything the wrong way, but I'm getting the right
Change
answers,
over
so it's hard for me to be like, this is bad, because it's working.
Pretty sure that's wrong.
All right, anything else? Going once, going twice. So stop you under camera.